Hey guys. All right, let's look at the warm-up. So part A, I'm asking you for the domain of f of x. You guys know that we can't take the square root of a negative number. So that's a pretty simple one. You can probably just look at it and tell me the answer. The other way you can think about it if you need like an algebraic process. Take what's under the radical and say that has to be greater than or equal to 0. So I know x has to be greater than or equal to -5. So with our interval notation, we would just say -5 to infinity. What's the square root of 0? It is. It's just negatives that cause us problems with square roots. So, we okay with A? All right. F of g of x. So you plug that 3x minus 7 in where there's an x over there. So the answer is the square root of 3x minus 2. That's it. Okay? Don't overthink that. Same thing with f of x over g of x. It's just the square root of x plus 5 over 3x minus 7. Okay? That one feels like, shouldn't I do more? But no, that's it. Okay? All right. Now on D, we do want to think a little bit here. This way. All right. We want domain of what we found in part C. So we have a fraction and we have a square root. So we have a couple things we have to think about. From the fraction, it's the denominator that I care about. What can the denominator not equal? 0, right? So I know that this 3x minus 7 cannot equal 0. So what does that mean x cannot equal? 7/3, okay. But then I also have that numerator with the square root. And you told me up above that based on that, I can only have values from -5 to infinity. So if you visualize it on a number line, there's -5, there's 7/3. I know it can't equal 7/3. And from the numerator, it can only be this stuff, right? It can't be anything less than -5. So your answer is bracket -5, 7/3, parentheses, 7/3 to infinity. Stop there for a second, make sure we're okay. Let me move it up for you again, sorry. Yeah, good, okay. Any questions on that? Okay, letter E, what'd you guys get for f of g of 2? 2, okay, everybody's fine with that? We remember how to plug stuff in to multiple things, okay. All right, are we ready for these lovely graphs? Yeah. No. Because if I plug into, so if I do g of 2 first, I get -1, right? So then I'm doing f of -1. Okay? If you were solving like x squared equals 4 and you took a square root to solve, that's when you have the plus or minus. But if you're just like, if I'm evaluating the square root of 9, it's not plus or minus 3, it's just 3. Okay? Good question. All right. Are we ready for this graph? Yeah. You could have just plugged it into where we'd already done that. Yes. Yeah. If you haven't already done that and it's ugly algebraically, sometimes it's easier to plug the number in and then plug that answer in, but it all depends on what the setup is. Okay, I'm going to do these in 2 different colors. I'll do 2 f of x in blue, and then I'll do the other one probably in green. What does a 2 out in front mean? Yeah, I see a lot of this. Multiply the y value by 2. So I'm just going to do each point and then connect and draw my new graph. So negative 4, 0, well, 2 times the y value, that's not going to change anything. 2, 3, sorry, negative 2, 3, that's going to end up negative 2, 6. Like that, and then 0, 3 would be 0, 6. 2, negative 3 would be 2, negative 6. 4, 2 would be 4, 4. Are you okay with the dots? And then I just connect them as best I can. Okay. Yes? That's the easier one for you guys, right? You're used to that. You're used to a nice vertical stretch. Anybody need it up here longer? I want to get rid of the blue so I can do another one and not confuse you. Yeah. You need a minute? Okay. Sure. I'll even move it up just a little for you. Are we good? Okay, let me get rid of the blue. This one in green. All right, what does a 2 inside with the x mean? This is the one we're always a little less sure about. Yeah. So it is a change to the x value, but they don't double. Thank you. So think about, what if in parentheses it had said x minus 3? Would you shift to the left 3? You'd go to the right, right? It's always like the opposite of what you think it's supposed to be. So this makes us think we should multiply the x values by 2. So what do you think we're actually going to do? Divide by 2 or multiply by a half? So this point negative 4, 0 is going to become negative 2, 0. Negative 2, 3 is going to become negative 1, 3. 0, 3 will stay. 2, negative 3 will be 1, negative 3. 4, 2 will be 2, 2. So that is technically a horizontal compression. Okay. That's what that looks like. Does that make sense? All right, we'll leave it there for a second. You good? Question, Alex, or are you sure? You can't read something, let me know. I could label this for you. That becomes 2, 2. 3. You people are still copying some things down. I'm going to go ahead and pass out your fake quiz while they're still getting that together.
No, you should have just scared us all instead of like quiz.
No.
Try not to talk
Okay. All right, guys. So again, take this like it's a real quiz. Once you've gone through the whole thing, if you still have some time and you need to look at your notes, you can. Eventually, I'll have you chat with neighbors, and then we'll go through all of it together. And I saw your email. These are totally fine. It's not gonna. And you didn't find them, so yeah. That's why they're all. I don't like that. No calculator.
I mean,
All right, guys, go ahead and get started. They should be taking their right chapter. Okay, guys. All right, so here is your piecewise graph. Ignore that it's like blue and red. That doesn't matter. This was just me graphing the vertex here, and then that end is open, that end is closed. Okay. Questions on the piecewise? Yeah, you need a minute? That's fine. Hey guys, just a reminder, make sure phones are away, not like sitting out somewhere near you. Thank you.
why is your large like the axles in the
It's got a, that's an arrow.
Oh, no way.
See it?
Wrong.
Okay.
But then it's still wrong.
It doesn't matter how I guess the slope of the line
I mean, technically it should cross in the right place, but your slope there is just -2, so here, I'll leave it.
If I go like this, I can just connect the line.
So like from that point,
still graphing.
so it's like halfway in between those two.
Yeah.
Okay.
Graphic while you can.
All right. Do we need more time on the piecewise? Okay, I see a couple people already. Scroll down. All right. Then question 2 here, guys. You're using the graph, or you can use the actual piecewise equations if you understand where to plug it in. It doesn't matter to me which way you do this. So f of -4 is 6. I can look at the graph. I need the filled in dot, not the open dot. F of 10, guys, for that right does not exist, or you can write D, N, E. Don't tell me undefined, because that implies that there's like an asymptote there or a hole, something like that going on, when really this is just not a part of your graph. Okay, 10 is not included in any of these intervals. And then F of 7 is 3. You okay with that? So again, just be careful with your notation there. And then domain and range on this next one. I don't do it this way. That's why that's a big X through it. Don't say I'm skipping the 3 and then I'm including the 3. You're either including it or you're not. The 3 is absolutely included in the domain, so you should say just negative infinity to negative 1, and then starting for a bracket at 1 to infinity. Same thing with the range. It starts negative infinity and goes to 6. I did not ask you number 4. My numbering is going to be a little off from yours now, but so this one, the negative f of x minus 3 plus 4, that's a reflection across the x-axis, and you're shifting to the right 3 and up 4.
Could you do the ice cream for the
Yes. Yep, that won't matter. The up 4, if you did that first, would throw it off, though. Questions there? Okay, and then this one, this is kind of what we talked about in your warm-up on those graphs. There is a difference when the 2 is inside with the x versus the 2 being outside. Were you guys okay with that after the warm-up? We see the difference there? Okay. All right, that's all on the front, right? Any questions there? Anything you need to go back to? What did you say?
I basically said x values times y1/2, y values.
That's okay. Yeah. Yep. Yep. Anything else?
So if it was f negative x minus 3, would that be infinity plus the constant y?
Yes. Yep. And if it was... That's really... So it's reflect across the y and then it's left. Yeah, okay. It's tricky. All right, let's go to the back. The back of mine I know got kind of messy here, so. All right, I'm guessing you were okay finding f of g of x, but maybe not so okay with the domain of that. Is that accurate? Yeah, okay. So let you jot that down, and then I'll go through the domain part. All right, so let's see, x squared minus 3x plus 2. Let me go through it over here. Okay, guys. So I'm asking you for the domain of this. We know what's under the radical has to be greater than or equal to 0, right? It's not as easy to tell on a quadratic as it is compared to a linear. Like the first one in your warm-up, it was easy. This is a little trickier. We need to factor it. And then what you're looking for is when is the product of these two factors greater than or equal to 0. So there's 2 ways you can go about doing this. If you're comfortable graphing the quadratic, you can look at it that way. Or I'm going to show you the number line test, which I think you guys saw last year, but probably not, you didn't use it a lot. So first, let's just graph the polynomial. What are your x-intercepts? 1 and 2, right? We factored it, so we found those 1 and 2. It's a quadratic, so you know your ends, your end behavior, they're both going to match, right? So are they both up or both down in this case? Both up. So is everybody okay with the graph looks something like that? Okay. I want to know, when is it greater than or equal to 0? That means when is it above the x-axis? So that would be from negative infinity to 1. And I can include that because I can take the square root of 0. And then again, from 2 to infinity. Because it's only below the x-axis in between 1 and 2. So that's one way. Yeah.
But what about the radical that the x squared minus 3x plus 2 is?
So the radical, like this is not the graph of the square root function. This is a graph of the quadratic under the square root function, so you can figure out the domain.
But does the domain change with the square root?
Yes, so the domain of the quadratic is all real numbers. The domain of the radical is this because what's under the radical has to be greater than or equal to 0. If I just said, find, you know, if the function had just been the quadratic, and I said find the domain, you would have said, great, negative infinity to infinity. But the quadratic is under here, and I know I can't take the square root of a negative number. So I need to be able to see which x values will give me positive answers under there and which ones would give me negative answers under there. The only things that work are negative infinity to 1 and then 2 to infinity. Like if you plugged in 1.5, which, let me give you another one just real quick. Sorry guys, I know we're slightly off here. Let's say we did x squared minus 5x minus 6. Let's find the domain of this. So we'd start by factoring this. So minus 6 plus 1. We'll do it graphically because that's the only way I've shown you so far. So where does this cross the x-axis? Yeah. Both ends are up, right? Are we okay with the graph? Looks like this. Okay, so that's the graph of the quadratic. The only values that will work in this square root are between negative infinity and negative 1. And then again from 6 to infinity. So let's plug in like 2 into this square root. What do you get if you plug a 2 into that? Yeah, can we take the square root of that? No, that's because 2 was in this region that's below the x-axis, which just means plugging in any of those x values will give me a negative value in the square root. Okay? We'll keep coming back to this. Let me show you the number line way with this one. And then if we have time at the end, we'll do another one. The number line method is very similar. You still start with whatever your x-intercepts were. And then you're just going to test the regions of your number line. I'm going to test with 0 because that's pretty easy to plug in. Which region of this number line would 0 be in? Like the left, the middle, or the right? 0? Oh, the left, okay. That's why I asked, because when I'm really, seems like 0 should be in the middle. So it's on the left. So what I'm doing is plugging 0 into these factors. So 0 minus 2 and 0 minus 1. Do you see how that would give me a negative times a negative? And what is that overall? Positive. Okay. Since I don't have any multiplicity going on with these factors, like it doesn't say x minus 2 quantity squared, I know my number line is just going to alternate. So if that region was positive, this region would give me negative values, and this region would give me positive values. So where is it greater than or equal to 0? The ends, right? Do you guys see how that matches up with the graph? I do not care which way you do this. I'm not going to ask you super complicated domain questions at this point. Later in the year, we will get into some things where the number line test is necessary. But with this, if you can just graph the polynomial too, that's fine. Whatever makes more sense to you so that you can see what the answer is at the end. Questions on that? I know that's probably the one you guys struggled with the most on this big quiz. All right, let's keep going, and then if we have time at the end, I'll give you another domain question to practice. All right, back to this. Okay, so number 8, we're just adding the two functions together. Feels kind of incomplete, but that's all you can do. It's just square root of x plus 4 plus x squared minus 3x minus 2. Domain for this one is much simpler. Your only restriction is that square root, and everything just has to be from -4 to infinity.
What if there was stuff there was 2 square root functions, would you just do i's?
So you'd figure out your restrictions on both, and then your answer is kind of where it overlaps, that they work in both. If one was like, you know, -4 to infinity, and the other was 2 to infinity, you'd have to go with the 2 to infinity, yeah. Which is, I think, is what you're saying, the higher one, yeah. Sometimes they're weird and they're like 2 ends, and then it gets trickier. All right, let's try again. Okay, here we're doing g of f of x. So you're plugging in that square root of x plus 4. You get x plus 2 minus 3 times the square root of x plus 4. Again, your domain is just -4 to infinity.
Yeah, I did understand.
Okay, do you have a question? You got it? Okay. The next one, find the inverse and determine if the inverse is a function. Both of the inverses are functions. I clearly did not have enough room or leave enough room for you guys to write the inverses. So let's see. I did them somewhere here. There we go. There are your 2 inverses. Did you guys do okay on the second one, or did you get stuck in the middle? Stuck? You're usually good to multiplying. Then remember, you want everything with a y on one side, everything without a y on the other side, and you can factor out the y, and then that gets you to your final inverse solution.
If my signs are the opposite,
All complete opposite, you're good. Yes, absolutely. And I will look for that when I grade. I won't just go wrong. It just means you moved your stuff to the other side, which is totally fine.
Oh, yes. I get it. I get it. Oh my God.
If you need me to go through any part of this process, let me know. Yes, absolutely. Guys, I'll also post the key right after your class for this one, and a blank copy of this, just in case you feel the need to do it again. For fun. All right, questions? I'm gonna keep going. I didn't ask. Okay, the graphs. Guys, on the one on the right here, the square root one, I should have told you 3 points instead of 5 for that. Since the square root only goes in one direction, graphing 5 points is super annoying, as I'm sure you discovered. 4? Okay, good. Yeah, the 5th one doesn't really fit on there.
Fit on the ground.
The inverse one?
Your razor sucks.
The cubic one? The other one. This guy, I know my numbering is off from yours. This one?
Yeah.
So, yes, this is the graph of this original one. And when I say graph, we're talking rough sketch. Okay, I know it's got a vertical asymptote. I know it's got a horizontal asymptote. You know that general shape, right? If I were to draw a horizontal line on this, it would only touch your graph once. So that means the inverse is, in fact, a function. Yeah. It gets very close when you're approaching that asymptote because it looks like it levels out, but it's always changing slightly, so it is a function. Yep. So the vertical tells me that this is a function, and then the horizontal one tells me the inverse is a function. Yeah, good question. All right, anybody need more time on the graphs? 2 seconds. You good? All right, then the last one was this IVT question.
Oh.
This is your 5 bullet point thing. I threw you off by saying h of x equals -2 instead of does it equal 0. So take a minute here, look at it. The first, the fourth, and the fifth bullet point should be simple. It's those 2 in the middle, second and third, that you've got to think about a little. And let me write the alternative way you could have done step 2. You could have said h of 2 is less than -2 is less than h of -3. And then you could have said -3 is less than c is less than 2. Like, those are other options you could have used for listing values on parts 2 and 3.
So when you're giving like the interval for the actual answer, it's like 0 points, do you do hard questions or soft questions?
Or which part?
Like if you're saying the interval is -3, -2,
Oh, like this just given to you?
Oh,
Yeah, you can go hard practice.
I want to make sure.
Yep. But those are part of what we're looking at. This we do not because we're saying C isn't going to be -3 or -2, but yeah. Yeah, just sign out of You could have used either these X's and done the whole interval, or you could use these X's. Either way is fine. If I just say that it happens somewhere on this interval, you can be like, yeah, somewhere else. It's a big old interval, it's fine. Exactly, yep. Yep, those two parts, yeah. Yeah. All no calculating. All right, guys. Again, for your assessment, that's coming up on Thursday. For review, there is a Delta Math review that you now have the code to as of this morning. So make sure you join Delta Math. You'll pretty much always have a review on there. I also posted a review attempt on all the math space homeworks in case there's some part you want to go back and practice again. There's another one up there. You guys as a class have done an awesome job of getting your homework done. I went through and looked at first and second attempts, and I think there's like 1 second attempt out of everyone in the whole class that needs to be done. So that's awesome. You guys are staying on top of your homework, which is really good. Other things to review. Look on Schoology, and there's some extra practice worksheets if there's something you're struggling with. Look back through your notes. You know, work through problems again from there. That's it, guys. I know the first one's always a little nerve-wracking. It is timed. You don't have the whole period for it, but it's also not super long. You'll have an hour to do it. It's similar to that, yeah. No, I'm going to switch you, but I don't know which one I'm going to switch you to. I'll post it, okay? Probably a lunch. Yeah, I will post it. I get too hungry if I eat lunch. Oh, thank you. Yeah.